Okay, folks, welcome to Trigonometry. One of the things that you should remember from geometry class is your right triangle trigonometry. The sine of an angle, and this is theta, by the way, and we will use this a lot. It's a Greek letter we use for angles. Excuse me. So this says that sine of theta is equal to the ratio that is created by taking the length of the side opposite of the angle divided by the hypotenuse. So I find a lot of students, after studying trigonometry for a while, will ask, how do you know which side is opposite? Well, this is the angle. If we indicate that this angle right here, this arc, is the angle we're speaking of, then the side on the other side of the triangle is the opposite side. Then the hypotenuse is always the one that is opposite the 90-degree angle, and the adjacent side is the one actually touching the angle theta. Now notice that the hypotenuse is also touching the angle, because this is the angle right here. This is theta. It has sides of this side and this side, and one of the sides will always be the adjacent side, and the other side will always be the hypotenuse. And just remember, the opposite side is way over there. And the cosine theta is a ratio that is created by taking the adjacent side, which is this one, divided by the hypotenuse, indicated here, and the tangent is the opposite side divided by the adjacent side. Now, to help you remember this, there's a little thing called SOHCAHTOA. So get this memorized, that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, now, the other thing that's important to realize too, and let's just get rid of some of those little marks. Oops. All right, I can't get rid of them easily. All right, I'll just leave them there. Is that, let's say we create another angle. Now, there's other Greek letters we use besides theta. So there's theta, and there's beta, and there's alpha, maybe gamma. Okay, some different angles that we use. So let's just call this one beta up here. Beta. All right, now, if we try to find the sine of beta and the cosine of beta, let's watch what's going to happen. We are not going to use the same opposite and adjacent sides. Now that this is beta, the side that's opposite of that is now over here now. So this is no longer the adjacent side of the angle. When you're looking at these opposite and adjacent sides, it's not the opposite and adjacent side of the triangle. It's the adjacent and opposite sides of the angle that you're talking about. Now we're up in the other corner. Now this side is the opposite side. Okay, so this is still the opposite side over the hypotenuse. But now this is the opposite side. And then this side is the adjacent. Okay, and this side is still the hypotenuse. The hypotenuse does not change in the right triangle. Just note that the adjacent and opposite sides will change because now we're talking about this other angle up in the corner rather than the angle that's down here. Okay, and we could have some lengths here and plug them in and just realize that the sine of this angle is not going to be the same as the sine of this angle because the opposite side of the angle has changed. Okay. Okay, one other thing that we have to talk about before we start solving some triangles are the 6 trigonometric functions. In geometry class, you only had 3. All right. All right, so as far as what you learned in trigonometry, in geometry class, whenever you had that, we just covered it. We just went over that in 2 minutes, sine, cosine, tangent, and defined what they were, just as a review. And so what you learned in geometry is done. Everything else that we're going to do for the rest of the semester is going to be completely new. So please keep up with this stuff. Okay, so make sure that what I'm about to write, you write in the exact same order and position as I am. So we have sine theta is equal to the opposite over hypotenuse. Now I know we're writing this again. Just write it again. Sine theta is opposite over hypotenuse. Now right below that, we are going to write cosine. And right below that, we are going to write tangent. Okay, write it exactly as I'm writing here. So that's adjacent over hypotenuse. The tangent is opposite over adjacent. Okay, now we're going to write the three other new trigonometric functions. And the way this is written, sine, cosine, and tangent, let's just look at the actual spelling of these words and how we say them, just so we know what we're talking about. The actual spelling of sine is S-I-N-E, and you say sine. This is the shortcut, the way you write sine, but you still say sine. You don't say sin, you don't say anything else but sine. Okay, this is cosine, and it's spelled cosine. And when you get down here, you still say cosine. You don't say cos or cos, you say cosine. Tangent is spelled like this, and you say tangent. Now this is one of the only one that you can say tan theta if you want. I'm not quite sure why. I say tan theta a lot, or tan alpha, whatever. But all the other ones you have to say as if they were spelled out. Okay, now the other three that we do not know. Now right to the right of sine, please put this one. The shortcut for it is CSC of theta, and that is spelled cosecant. That's an E. That's the cosecant. And I'll write some stuff here in a minute. This one, the shortcut way is SEC, and that is secant. And again, on these, you don't say CSC, you don't say kisk, in this one, you don't say sec or seek. It's secant. You say it as if it's spelled there. And this one is COT. You do not say cot or cot. You say cotangent, because it's the cotangent. Okay, just so you see it spelled out. Now, there's a reason we put it in this order. Talk about that later. You have to put sine, cosine, tangent right like this, and you have to put cosecant, secant, then cotangent. And these three on the right are simply the reciprocals of the one on the left. That's one of the reasons we put them like this. So the cosecant then is the hypotenuse divided by the opposite side. The secant is the hypotenuse divided by the adjacent. And the cotangent is the adjacent divided by the opposite side. So these are reciprocals, straight across, back and forth. Now they're reciprocals of each other. So if you know one, you automatically know the other one because you just take the reciprocal of it. So those are just reciprocals. Now, kind of the way that I remember this is you should know sine, cosine, tangent, and then I know that the ones on the outside here are C's. If you notice the ones that have C's, they kind of make a triangle. They kind of make a triangle like this. So the C is in the middle here, the C's are on the outside there, and the cotangent goes across from the tangent. To help you remember that orientation right there. Okay, let's do some problems then. Okay, one thing, oh, a little glitch there. All right, one thing that I'm always going to do on these problems is to write an answer box somewhere. So let's write an answer box. So we're going to write out, and notice here that we have an, maybe that's an, I can't tell if that's an A or an alpha. So let's just make it an alpha. So sine of alpha, and then we have cosine of alpha, and these are supposed to be equal signs right here. Gonna mess that up. And we have tangent. And then over here, we're gonna write cosecant, secant, and cotangent. So make your answer box. No work can go inside the answer box. Absolutely no work in there. Yep, that's where the answer goes. No work, no reducing fractions, just answers inside the answer box. Just like when we make factor boxes. Okay, so let's get this done. So let's calculate then the sine of alpha. The sine of alpha is the opposite over the hypotenuse. Now if you need to right away, we can draw a little arrow over here. So this is the opposite side. You can put an O there or an opposite there. This side is the hypotenuse because it is across from the 90-degree angle, and that leaves the 15 as the adjacent side. And again, it's not the adjacent and opposite side of the triangle. It's the adjacent side and the opposite side of the angle that we are addressing at the time. So we have A. Here's A right there, and the opposite side is the 20 side. Okay, so the sine then is opposite side, which is 20, divided by the hypotenuse, which is 25. Okay, now here's the work I'm talking about, is that we can't leave it 20 over 25 because it reduces. So I notice that a 5 goes into both of these, so that will reduce to 4/5. And then this is the answer that we write up here as 4/5. Now here's the easy part. The cosecant is simply the reciprocal of the sine. It is the hypotenuse divided by the opposite. Now actually pause there a little bit because I don't really have these memorized. All I know is that they're the reciprocals of the sine. So once I have the sine 4/5, not much thinking goes through my head. I just write, hey, you know what? I'm just going to take the reciprocal of that. 5/4. And it's that easy. Once you know these, you know the other ones automatically. Okay, cosine. Cosine of alpha is the adjacent side now, which is 15, divided by the hypotenuse, which is 25. And again, I see 5s go into both of those, and that will reduce to 3/5. And up here, we write 3/5. And without much thinking, I'm going to come right over to the secant, and I'm going to write the reciprocal, which is 5/3. And the tangent is the opposite side. I'll write this one down. And you can either write this or not, if you remember it. Tangent is opposite side divided by the adjacent, and the opposite side is the 20. And the adjacent side is still the 15. And again, all these numbers have 5s that go into them. So this one is 4/3. And you write that down. 4/3. And then you just come shooting right over here, and you write the reciprocal, which is 3/4. And we're done. When you're done, you have all 6 trig functions, because that's what it says up here. I never really read the question, but I just kind of knew what to do. Find the 6 trigonometric functions of alpha, and that does look like an alpha there. So, and then we're done. That's it. All right, let's make an answer box for part B. Okay, I went ahead and made an answer box. And you don't necessarily need to actually put it in a box, but again, you're not allowed to put any work here next to the trig functions. Okay, now this one is going to take a little bit more work. All right, so now we have alpha is up here. So then if we come down here, that side is the opposite side. This side is the hypotenuse because it's across from the 90, and that leaves this side as the adjacent because it's touching the angle. Okay, so sine. Let's do some work here. Okay, so the sine of alpha is the opposite side, which is 3 root 3, or 3 times the square root of 3, over 6. And we're always looking for things to reduce. Now, you cannot touch a number that's inside a radical and outside, but you can touch two numbers that are outside. So I see that a 3 goes into both of these, so I'm going to divide this by 3 and get a 1, divide this by 3 and get a 2. So we have 1 root 3 on the top. I'm not going to write 1 root 3. I'm just going to write root 3 because it's 1 times root 3. And on the bottom, we're left with a 2. So sine of alpha is root 3 over 2. Now, the cosecant then, we have to do a little bit of work with this. The cosecant then is going to be the reciprocal of the sine. Okay, so I'm going to take that value I had got for sine, and I'm going to take the reciprocal of it and get 2 over root 3. Okay, and then we have to rationalize the denominator. This is something that you've done in the past. Let's hope we remember how to do this. We'll do it, of course, but let's go through it. So whatever there's a radical on the bottom. Now, if there's another number next to it, I kind of ignore that for a moment, and I only look at what the radical says. So I don't have that in this case. And we're just going to multiply the top and the bottom by the radical that we see. Now on the top we get 2 times root 3. And on the bottom you get root 3 times root 3, which is 3. And then we're done. 2 root 3 over 3. You cannot leave a radical in a denominator. Okay, you also have to have simplified radicals, like we simplified radicals during the quadratic unit. So don't leave anything like root 50, where you can pull out a perfect square root. That would turn into like 5 root 2 or something like that. So just be aware of that if we run into that. All right, so the cosine then is the adjacent side. So the cosine of alpha is the 3 side over the 6 side. So we write the adjacent over the hypotenuse, and 3/6 just reduces to 1/2. So we write 1/2. Okay, now as far as the secant goes here, we really shouldn't have to do any work, but you just take the 1 over 2 that you found, the cosine, and you take the reciprocal of it, which is 2 over 1, which just simplifies to 2. Don't leave anything over 1 ever. Okay, so the secant is 2. That one's easy. Then we do the tangent. It looks like the tangent's going to be pretty easy. It just cancels out, I think, here. So the tangent is the opposite side, which is the 3 root 3. And we're going to divide that by the adjacent side, which is 3. And then that 3 and these 3 cancel because it's multiplication. You can't cancel from addition, but you can cancel multiplication. And we are left with square root of 3. Oops, forgot square root. There we go. Okay, now the cotangent then is going to be the reciprocal of that. So the first thing we should do is maybe put this over 1, and then when we take the reciprocal of it, you should see it becomes 1 over root 3. Okay, and again we have to rationalize that denominator. We can't leave it the square root of 3 because the square root of 3 is an irrational number. And we multiply top and bottom by root 3. On the top, we get 1 times root 3, which is root 3. And root 3 times root 3 is 3. Okay, let's write that down. And we are done. We have all 6 trigonometric functions. They are fully reduced. There are no radicals in the denominator, and there are no 1s in the denominator. And every fraction is simplified, and we are done. Okay, so this is just a quick example of how to find some reciprocals. So we already know sine, cosine, and tangent, so we don't need to write those down. But let's write down the cosecant. And we're finding the angle is theta there, so we're going to write those down. So it's cosecant, secant, and cotangent. Okay, so given sine theta is root 5 over 3, that tells us that the cosecant is the reciprocal of the sine, so that is 3 over root 5. And we rationalize that by multiplying by root 5 over root 5, and that gives us 3 root 5 over 5. Okay, secant. Secant theta is the reciprocal of the cosine. So the cosine is 2/3, so that one is easy. It's just 3/2. Not a problem. Cotangent. Cotangent is the reciprocal of the tangent. The tangent is root 5 over 2, so we take the reciprocal of that, 2 over root 5. We multiply by root 5 over root 5, and we get 2 root 5 over 5. And we're done with that one. Okay, let's get rid of that little guy. Okay, so we need to find the 6 trigonometric functions. So let me pop that in real quick. Okay, I created a little answer box. So I'm ready to go. Okay, so given one trigonometric function value, find the other 5. Okay, so let's give one here. So let's put down our given. So let's just make one up here. So given, let's say sine theta is equal to 2/3. Okay, how do we find all the other ones? Well, it's just a little process we go through. First thing absolutely you have to do is make a sketch. And we make a right triangle. The best we can. Alright, put in a little right angle. And you have to put theta in somewhere. You can put theta wherever you want. Don't put it in for the right angle. Put it in as one of the other acute angles. Okay, just put it in there somewhere. There is theta. Now, this side then will be the opposite. This side will be the hypotenuse of the angle. And this side is the adjacent side of the angle. Okay. Well, we know sine is 2/3. So this is all about being a ratio. So what you do is, if the sine then, which is equal to the opposite, divided by the hypotenuse, you just label the opposite side with a 2. And you label the hypotenuse with a 3. Okay? Now, just like I think it was the first example we did, we had triangles, 2 triangles, and we had all 3 sides. Well, in this one, if you notice, we do not have all 3 sides. We only have 2. So we have to go find the other side. Well, here we go. Let's just call this x for now. And we're going to go find the other side by using the Pythagorean theorem. I'm going to do that up here. So we have that one side of a triangle squared plus the other side of a triangle squared is equal to the hypotenuse squared. And then you just solve for x. So we have x squared plus 4 is equal to 9. X squared is equal to 5. And we have x equals plus or minus the square root of 5. But we should know that a triangle cannot have a negative side length. So now we know that the adjacent side is just root 5. Now this kind of seems familiar to something we already did, and I don't really care, but we're just going to go through this. Okay, so theta then. Theta is the opposite side over the hypotenuse. So, or sorry, sine of theta. Sine of theta is the opposite over hypotenuse. I went in the wrong direction. So that's 2 over 3. And we put 2/3. Then we can immediately write the cosecant as 3/2. Okay, then we can calculate the cosine. The cosine is the adjacent over the hypotenuse, and that's root 5 over 3. Okay, there's no reducing there, so we can write that down. Root 5 over 3. And the secant then is going to be the reciprocal of that, which is 3 over root 5. And we have to rationalize the denominator, root 5 over root 5, and that gives us 3 root 5 over 5. Okay, tangent. The tangent of our angle is 2 over root 5. Now, we're going to be back to this in a second when we go to find cotangent. Okay? This is, you'll hear me hopefully say a couple times, don't re-rationalize a denominator. So here's what we're going to do the first time. So let's just write down 2 over root 5 because that represents the tangent, and I have to rationalize that. So we multiply top and bottom by the radical, and we get 2 root 5 over 5. And we can write that down for the tangent. 2 root 5 over 5. Now, look at what we have here. Look at what I already boxed off. The tangent is 2 over root 5. But then I simplified it and made it 2 root 5 over 5. So let's think about that. If tangent in its simplified version, or its proper form, is 2 root 5 over 5, if we go to calculate the cotangent, look what happens. We get 5 over 2 root 5. And then we have a mess here that we have to rationalize that root 5 again. But remember, we don't want to re-rationalize the denominator. When we calculated the tangent, I had to rationalize the denominator, which tells me if we just look at this box right here, and let's just write it again, if we use this original number we wrote down, 2 over root 5, and then we take the reciprocal of that, it's going to be a whole lot easier. So notice that the cotangent of theta, just take the reciprocal of this one, not the more complicated one. The reciprocal of this one is just going to be root 5 over 2. And we can write that down. And then we're done with that one. Okay, and just kind of recap what just happened here. When you have one of the functions and you notice that the radical is in the denominator and you have to rationalize it, when you go to find that function's reciprocal, like the cotangent, if you had to rationalize the denominator, you're going to have to do it again. To avoid that, use the original fraction that you wrote down. And when you take the reciprocal of that, you get something nice and easy that you do not have to rationalize. Okay? We'll do more of those if you didn't understand that, but I don't want to make this video longer than it is. Okay, so I'm going to do 2 examples on this page. Okay, so for the first one, we are given that the cosecant is equal to 2.5. Now, in all of our answers, we are not going to use a calculator. Notice I have not mentioned one thing about a calculator. We're going to reduce our fractions, and we are not going to have decimals in any of our answers. We are not allowed to have answers. Okay, so then you're looking at this going, well, the cosecant says 2.5. Well, we're not going to write that down. That's not our answer. Okay, so we have to change this to a fraction. So simple thing to do with any number to turn it into a fraction is to write it over 1. And we have to convert that to a nice fraction. Now, some of you might already know what the answer is, how to write 2.5 as a fraction, but I'm going to show you how to convert any decimal that you have to a fraction, and not just maybe an easy one that we have here, if you already know what the answer is. All right, if you have a decimal, an easy way to do this is to simply multiply the, let me get rid of the equal sign, is to simply multiply the top and the bottom by powers of 10. So you can multiply by 10, you can multiply by 100 or 1,000, whatever you need to do to get rid of the decimal. So I see that 2.5 has only one decimal place. So if we multiply the top and the bottom of this fraction by 10, or multiply by 10 over 10, here's what we get. So 2.5 times 10 is just 25, and on the bottom you get a 10. Now that's not fully simplified because a 5 goes into each of those, and that reduces to 5 halves, and we can write that down for cosecant. So see that we have a nice fraction there. The other thing we can do just quickly is we know the sine here, and we can write 2 divided by 5 because the sine is just the reciprocal of the cosecant. Okay, so at some point here we need a triangle. Let's draw that up here. All right, little interruption, that's okay. All right, so let's put our angle anywhere we want. We have theta right here. So this is our opposite side, this is our hypotenuse, this is our adjacent side. All right, so if we have that the sine is 2/5, now this is one reason that I didn't really think about it to draw a triangle first, because I don't like to draw the triangle with the cosecant. I know sine, cosine, and tangent very well. So once I had cosecant, I wanted to find sine before I drew the triangle. So that tells me that sine is opposite over hypotenuse. So this side is going to be 2, and this side is going to be 5. Now again, we do not have the adjacent side, so we need to put an x right there. Now be careful when you're making these calculations. I'm going to do that down here. So we have x squared plus 2 squared is equal to 5 squared. So we have that x squared plus 4 is equal to 25. And that gives us that x squared is equal to, looks like 21. And then x is going to be the square root of 21. Okay, so this side is square root of 21. And then we're ready to go with everything else. So cosine. Cosine is going to be the adjacent side, which is root 21 over 5. And there's going to be no reducing with that one, so I'm just going to write that down. Root 21 over 5. Okay, the secant then is going to be the reciprocal of that. So to calculate the secant, I'll do that over here. The secant of theta is going to be the reciprocal of the cosine, which is 5 divided by root 21. And after multiplying top and bottom by root 21, we get 5 root 21 over 21. Okay, tangent. Do that one here. Okay, tangent is opposite over adjacent. The opposite side is a 2. The adjacent side is root 21. All right, now here's another case I can see right away, like the last one. I'm going to need this for the cotangent, and I'm going to take the reciprocal of that. But for now, I'm just going to multiply top and bottom by root 21 to get tangent. So that's 2 root 21 over 21. I'm going to write that down for tangent. 2 root 21 over 21. Now again with the cotangent, if we try to take the reciprocal of 2 root 21 over 21, that's going to be a complete mess, and we're probably going to make a mistake. So let's just take it right off of this one. Okay, now remember my kind of saying is don't re-rationalize the denominator. So the cotangent here, just take the reciprocal of this one. So if you write a function down and you see a radical in a denominator for its reciprocal, just take the reciprocal of that thing, and notice that you just get root 21 over 2. All right, if this were not a video, I would probably show you how to do it the other way as well, by taking the reciprocal, but again, I don't want to make this too long. All right, to make sure this thing processes and stuff in time, I am going to stop this video, and I'm going to restart here in the next video.